To evaluate an arithmetic sequence, in essence, we're going to be finding the sum of the first specific number of terms. So to find that sum, again, this is a formula that I would just write down and keep handy because it's a pretty easy formula to use. What we're going to do is we're going to find the sum of however many, and so that n, that sub n, will tell us how many terms we're actually finding the sum of. So for instance, first we're going to use it without this formula. Let's just find the first 6 terms of this sequence. So we're going to add 3 plus 7 plus 11 plus 15. Now what would the next terms be? Well, I added 4, so it looks like my common difference was 4, which means that the next term would be 19, and then the next term after that would be 23. Now, I can just use my calculator and add all of those up, but I want to show you something. If I take 3 plus 23, I get 26. And if I take 7 plus 19, I get 26. And if I take 11 plus 15, I get 26. So I get 26 3 times. There were 6 terms, and I got 26 3 times. Notice what our function here is doing. It's taking 6 divided by 2, which would give me 3. And then it's taking the first and the last term, the 3 plus the 23, and adding them together. And then that's exactly what I'm finding here, is that I had 26 3 times. And that's going to be my sum. And so 3 times 26 is, of course, 78. Now, using the formula, again, I have S sub 6 is 6 over 2. The first term was 3. The 6th term we would of course have to find, and we've already found that it is 23. And that gives me 3 times 26, which gives me 78. So this is the easiest way to go. This one I gave you an easy one because it was 6 terms, so we actually could list them all out and add them up. For this one, we want the sum of the first 35 terms, and that would sort of be asinine to go through and find all of the terms and then add all of them together. So instead, I just need to use my function, which I've written up here in the corner for you. And the only thing I really need to be able to do that, because I know that n is going to be 35, what I don't know is a sub 35. So I need to find that first. So remember that a sub n, I probably should have written that one for you as well, is the first term plus n minus 1 times the common difference. So that's what I need to do first to find a sub 35, so I can plug that in here. So a sub 35 would be the first term, which is 1, plus 35 minus 1 times the common difference, which looks to be 2, since I was adding 2. Which means the 35th term is 34 times 2 plus 1, so that's 68 plus 1, or 69. So a sub 35 is 69. To find the sum of the first 35 terms, I'm going to take 35 divided by 2, and then I'm going to take 1 plus 69. So that's 35 halves times 70. 70 and 2 reduce. So basically I have 35 times 35, and that gives me 1,225. So again, instead of having to write out 35 terms and then use my calculator to add them all together, I just used both of my functions to be able to do that. Here's another one. They want us to find the sum of the first 22 terms. And again, this is using that summation notation instead. So I know that the first term is 8 minus 5 times 1. So let's find a sub 1. A sub 1 is 8 minus 5 times 1, which is 3. And then a sub n, which is obviously 22, would be 8 minus 5 times 22, which would be 8 minus 110, which would be negative 102. So there's my first term, my 22nd term. To find the sum, I've got 22 over 2, and then 3 plus negative 102. 22 over 2 reduces to 11. 3 plus negative 102 gives me, whoops, that's multiplication, not addition or subtraction. That gives me negative 99. And then I'll multiply those two together. And that gives me negative 1089. So that's the sum of those terms. Here are two for you to try on your own. So try them both and then press play to check your work. So for the first, we're finding the sum of the first 27 terms of the sequence. Again, we have the first term, so a sub 1 is 10. I don't have the 27th term, so I need to find it. So a sub 27 would be 10 plus n minus 1, so that's 26, times the common difference, which appears to be 4. That gives me 10 plus 104, or 114. So a sub 27 is 114. To find the sum, I'm taking 27 divided by 2, and then the first term, which is 10, plus the last term, which is 114. That gives me 27 over 2 and 124. Half of 124 is 62. And so I reduced those, so 27 times 62, which is 1,674 would be the sum. For the other, again, this is written in summation notation. I still need the first and last term. So a sub 1 would be 3 times 1 minus 2, which would be 3 minus 2, or 1. And then a sub 15 would be 3 times 15 minus 2, which is 45, minus 2, which is 43. So to find the sum, of the first 15, I guess I should have written 27 here. To find the sum of the first 15, I'm taking 15 over 2, and I am multiplying that by the sum of 1 and 43. So I've got 15 halves times 44. The 2 and the 44 would reduce, so it's really just 15 times 22, which is 330. 330.